Hey, physical science Sasquatches. Looking at our quizzes last week, we did not do a great job on understanding specific heat, so I'm going to extend that lesson into today with some quiz questions, and I figured instead of using other videos, I'm just going to make my own here. This is what we would have done in class. So you're in your heat temperature, and hopefully by now we understand heat has to do with thermal energy, moving from hot to cold or high to low. But there's another important concept we need to understand that's called specific heat, and it's different than just normal thermal energy. So what it's really defined as, specific heat is the amount of heat, in joules usually, the amount of heat it takes to raise the temperature of 1 gram of substance 1 degree Celsius. Now that sounds really complicated, but what that means is we just measure how much energy it takes to make a spoon raise from 56 to 57 degrees, and that amount of heat is its specific heat. The reason why it's called specific heat is because it's very different for every substance, and it's specific to whatever that material is made out of. You guys know if I leave a metal spoon in the pan versus a wooden spoon in the pan, they're going to heat up differently because of their different specific heat. So it's kind of a complicated definition, but it really makes sense. The units of it kind of reinforce this. What the units of specific heat usually are joules per gram degree Celsius. And what that's saying is it's the amount of joules of energy it takes to raise 1 gram of that thing 1 degree Celsius. And we just use those 1 grams and 1 degree, so it's nice and standard. Let's dig into some real life examples here. If we look at a table of different specific heats, you can see that every single substance has a very specific value because it's different because of the atoms. One of the most important things about this is you will see that a lot of things down here that are metals have very low specific heats, and that makes a lot of sense. If I hold a metal stick in a fire, like a campfire or a hot dog roaster, it heats up really fast, which is why its specific heat is so low. It does not take very much energy to make a iron stick heat up because of the way that a metal atom works. If we look on the other hand, water has one of the highest specific heats of all substances on Earth, and that's very important. That's why if I leave a metal pan on the stove like these right here, they heat up really fast because of their low specific heat. It takes 10 minutes though to boil water on the stove because water has a very high specific heat, and what that means is it takes a lot of energy to change its temperature or to heat it up. Here's the same table. Here's some real life examples. We've already kind of talked about, for cooking we use metal pans because of their low specific heat, and they heat up and transfer the heat really fast. If I leave a metal spoon versus a plastic or a wooden spoon, a wood would probably be up here between water. A metal spoon will heat up way faster because of its low specific heat, whereas a wooden or plastic spoon takes a lot longer to heat up, and that's why a lot of your kitchen utensils aren't made out of metal, because of their high specific heats. When we talk about water, its high specific heat is very important. If water heated up fast, an animal like a lizard or any animal in a desert would die right away because with its body being made out of water, the temperature of the animal would rise really fast, which would make it die. We know that a lot of our bodies are water, 70% or so. That's why I can go out on a hot day and we don't have to deal with a lot of problems because the water in our bodies takes a long time to change the temperature of. This is also why even when it's going to be nice out and 80 degrees this week, swimming pools are still going to be really cold because it takes a lot of energy to change the temperature of water. We talked last week, and this is what your quiz is going to have. We did not do a great job on our climate question, but if we look at California, California's temperature is 70 degrees almost the entire year. It's not because it's closer to the equator or farther from the equator. It's because California is close to a huge body of water, and what we've really hopefully hammered home here is that water, it takes a lot of energy to change its temperature. So all that moisture and all that water in the air by California takes a lot of energy to heat up, which is why it doesn't change very much. Whereas for Nebraska, we have very dry air, and if you go look at dry air right here, we're not close to any bodies of water. Dry air is easy to change the temperature of compared to water. That's why in Nebraska it's going to be 40 degrees this morning and it's going to be 75 degrees later because it does not take a lot of energy to change the temperature of air. That's why California's temperature is consistent and ours is crazy. This also has to do with insulators and conductors. Obviously, if something's an insulator, we want it to hold heat really, really well. So that's why if you look at some Yeti coolers, they have some water in their styrofoam to help hold that temperature in. Conductors, on the other hand, are things that we want to transfer heat and heat up fast, which is why down here most of our conductors are made of metals because of their low specific heat. Hopefully that helps you kind of understand that better. Ask questions if you have it.